I'm gonna have to wait more to see if it's streaming because I had to redo my setup. I'm just gonna wait. Then I'm gonna talk about what I'm gonna do today. You're probably gonna explain first why I'm doing what I'm doing now, what I'm gonna try to do now. Let's see if it's streaming. Yeah, so it looks like it's streaming. So I had to redo a bunch of, not a bunch, but I had to redo some things that I was doing on Godot, and I decided to, since I was redoing everything, I decided to get the most recent code from GitHub, from their source code, and I had a problem, which I'm not really sure. Like, I think it doesn't come from my code; it comes from their code, but I'm not really sure if it's something that they done or if like it was because of the previous configuration I had Vulkan. Because I think that the GPU that I'm using, it doesn't support Vulkan, but I had installed Vulkan before, so it might be might be the case that because I don't have Vulkan now is exposing this problem. And also I'm using a different compiler, so I'm using MinGW on Windows, and before I was using Visual Studio. So because of these two things, I think that's the reason why I got this error that I'm getting now. So compile, I'm doing a fork of Godot, and I'm doing like modifications to make it so that I can develop faster. So that's basically the whole idea. And now it is working, but when I run, it shows a bunch of error messages, which is very annoying. And I was trying to figure out how to solve this. And I was gonna go over with the debugger, but I didn't lose because I had cached the configurations, but I had to, because of the compiler, I'm using a different compiler, I had to redo the configurations, but then they were not working, and the reason why is because of the way that I don't have the extension, the VS Code extension, is because of the way that it works on VS Code to set up a debugger. So because of this, yeah, so it shows a bunch of error messages there. And I think it has to do with the graphic. Maybe it's something that they changed recently from I was using 4.3, and this is the 4.4 version. But I think they solved a bunch of things, so it's probably better to use the most recent one. But now I want to see, like, if I can't remove the errors, I want to figure out how to, like, if I can't fix the errors, I want to figure out how to remove them so that it doesn't crowd the space here. And because of that, I was trying to figure this out, but then the way that it works on VS Code is that, so still it's not very clear to me, the nuances, but it's basically a model view controller pattern where the part of the logic that is responsible for interacting with the GUI is on VS Code source code. So when you press here, for example, it's like VS Code's responsibility. But the parts of the debugger is like a bridge that they create using this other code other source code that they created. I think that like this is just the protocol, debugger adapter protocol. So it's just like a standard, a series of rules for creating communication between the front end, which is the GUI from VS Code, and the back end, which is the debugger. And on top of this, you need to create another thing, which is this one that they use for Visual Studio, and I think for GDB as well. That like this is essentially the code that is going to use the debugger adapter protocol to communicate with. So like it's going to go from the GUI, and the GUI is going to, as far as I understand now, I could be wrong, but that's how I think about it. So you're gonna click here, for example, then the GUI is gonna send an event, and the event has to be formatted on the debugger adapter protocol. That's gonna be accepted by this source code, and this source code is gonna spawn an instance of the debugger depending on the type, and then it's gonna communicate back and forth between the debugger and VS Code. It's like a standard protocol for communication from between them. But this only works if you have the Visual Studio Code's extension, the Microsoft extension for C++. And I still want to try to avoid using that and use my own. So I have the code for the extension here somewhere. It's basically this code here. No, this is the one that I was creating. So I think it's probably on downloads. Yeah, so this is their code. And then based on the extension is gonna I still don't know the nuances, but it's gonna load this code here. So I think the way that it works is that they compile this before and it becomes an executable, and then they use Node.js to spawn the executable from the VS Code extension. So the types here on the launch.json, they only matter in the context of using the Microsoft extension, because based on the types, it's gonna determine the control flow that is gonna set up the state of this debugger here. So what I was trying to do, and I'm still trying to do, is figure out how to create my own extension with my own debug adapter, so that I can control the full process and I don't have to do this setup all the time. It's basically this extension here, the VS Code tools. Yeah, this extension. And in order to do this, I was trying to study this thing here, and I was using ChatGPT to do this. But then I realized that it's kind of annoying, because with ChatGPT, it's obviously better to cache the information, and because you lose the context with ChatGPT, you have to spawn a new chat so that it doesn't go over the context window, and is lower. So I was thinking about, which I was already gonna do before, it's already my plan to do this at some point. But then I figured that because I'm trying to do this right now, I'm just gonna figure out how to do it, how to incorporate the LLMs locally. So I have so it becomes faster to learn the code base. Instead of asking ChatGPT about a bunch of questions, I can figure out how to incorporate the LLM so that the LLM studies the source code and then creates everything. But then I find out that there's a Meta guy that did this, which is this source code here. So they created this other source code, which is this Pocket Flow. And then they build on top of this on this other repository here. And this is the channel from him. And they did basically what I was trying to do. And if you know me and you've watched the live streams, I've been wanting to do this for a very long time. So it looks like he was able to figure out a way to do this automatically. So this is what I'm gonna try to do now. But also I wanna try to see if I can do variations of this. So as far as I understand, basically the way that it works is that you put the command there and you pass. So there's two different ways that I'm gonna explain. But the way that I'm trying to do now is with an API. But obviously you can do it with a local LLM. So the local is much better, because another thing that is kind of annoying me is that if you lose internet connection, then you don't have access to the AI. So, and obviously because of privacy, I don't want people to read the conversation. It's better to have the LLM be private. And for that reason, I think it's probably better to have the local LLM, but then you are limited by your resources. I can't use the GPU because my GPU is not very good. So I have to choose the CPU version, and it takes a massive amount of RAM. So I'm still trying to find a middle way. So I think probably the best way to do it, if I use ChatGPT as well to try to figure out this strategy, is basically use the APIs to create the beginning of the process, and then use the local LLMs for work that is not as intensive. So you create a funnel. Basically the way it works is you run this command here, and then I'm gonna study the source code now, but I think the LLM is gonna go traverse the GitHub repo you pass here, and it's gonna create these documents that explain the design of everything and how everything's connected. So the thing that I'm trying to do is to use this to study the MI engine, and create the debug adapter, then study the C line here, which C line I think is a Microsoft VS Code extension. It's not from Microsoft, but I think it's a VS Code extension that allows you to incorporate the LLMs as well in VS Code. But the problem with this one is that there's a bunch of telemetry, as always. So I want to see if I can study the source code here and also change this as well. And the idea is to be able to bootstrap this on Godot eventually with my own IDE. So yeah, that's what I'm trying to do now. And the other thing is for local LLMs, you can use this Uga Buga or text generation web UI, which is another code that these people created, which allows you to run a chat locally as well. So like there's two main strategies. One, like the difference is that this one uses local LLMs. So it has some code that does API request, does HTTPS requests or HTTP requests, I'm not sure, to Hugging Face. And Hugging Face is this website that they provide a bunch of models that you can download. So what I did obviously is search for a bunch of models that I thought was the best, and then I downloaded a bunch of them. But the problem is, like I said, you're limited to the RAM you have and to the GPU speed if you're gonna do this locally. But it's also, so the idea that I have, one way to go about doing this is to extract the code from this text generation web UI to communicate with to do the inference locally and put it on the other flow so that instead of doing the API request, I can use the local LLM. But for now, the strategy that ChatGPT recommended is to either use OpenRouter or Grok, which are two different places where you can get APIs for free. It has rate limits, but this is the whole strategy. Is like use the free stuff, then use that to study the other stuff, build the other stuff, and then we bootstrap the process. And then once you bootstrap, you can use the local LLMs and you can automate so that the speed doesn't matter. And obviously I can find the ways to optimize to figure out if I can use less RAM. So maybe I think I'm gonna run this. And surprisingly, the very nice thing about this is that I didn't got any errors when building, which is very, very hard. Usually because of these things, very complicated because you have so much variance over operational systems and then the libraries and the versions and everything like that. So it's extremely hard to make the build system work the first time. But I didn't do anything here to make, like, it's kind of complicated as well because like this is a batch script that they provide and it builds everything for you, but then you can't run the Python commands outside of the batch script because of the environment. So this is gonna set up a conda environment and it's gonna set up like the Python instead of the conda environment. So in order to make the debugger work, it's kind of annoying, but it's not that annoying because you just use ChatGPT to build. I'm probably just gonna show there. But this runs a local server and allows you to, I think I'm probably not gonna, maybe I'll try the smaller models because they take a lot of RAM to do the inference. And the nice thing about this one is that you can do extensions or you can hack here and put your own module, like create your own module. And then basically you have like freedom to customize however you want. Yeah, but this command here basically, so debug by is a debug adapter for VS Code. And all debuggers are gonna work like this. So the type doesn't matter. What matters is the debug adapter. And there are some debug adapters that are embedded on VS Code. And I think that this is one of them. Node.js is probably the other one. But if you want to debug other languages, then you either have to find the debug adapter or you have to create your own. And then you make the bridge. So basically, VS Code's code is just it's going to provide the interface for the UI, and then it's going to send messages. And then the rest of the stuff, as long as you know what messages it's going to expect to receive in the order, you can use the other stuff to create your own debugger. So on C++ example, it's going to be like, if you're using an open source compiler, you're probably going to use GDB, which is a C++ debugger. And then as far as I understand, based on what ChatGPT said, which I think makes sense, like VS Code is gonna send a signal for the debug adapter to say like, hey, initialize the process. Then the debug adapter is gonna communicate with the debugger, and the debugger is gonna launch the actual executable. And by the time that happens, it already has all the breakpoints that it should set. So it sets all the breakpoints on the process using GDB commands, and then it sends the signal back to the debug adapter, which sends to VS Code, which synchronizes with the UI. And so it opens here. And then allows you to talk. I was having problems with the internet, so I was trying to figure out. And here also I created an extension, so basically here you can put system prompts. So I did an extension that puts this by default there. And then I have the models here. So I downloaded a bunch of them, and they're gonna be, after you download them, it puts on the local files, either on, I think it's on models, yeah. So there's the actual models, and it has to be, if you're like me and you only have access to the GPU or to the CPU, then you should download this GGUF models, because I think they are like the optimized version. They strip down the memory. It's a quantization, something like that. The name of this. And I think they use Llama CPP to do the inference. So here, the way that this one communicates, as far as I understand, is you have to get the API keys, or I'm gonna change it, like I said. This one I just got the code from ChatGPT. So I haven't tested it yet. I just tested like running this file directly, but I didn't test to build the whole thing. But obviously the APIs provide some codes. The Grok is from OpenAI, and I think that is free at that until some rate limits. So yeah, you just run this code with the API, and I think what it does is to get the link that you send there. So I haven't seen anything, so I'm gonna study now. It's probably just getting the code and then formatting a prompt to the LLM. They're just gonna generate, I think it generates the resources based on JSON. Let's try this one. This, from where I'm seeing, the recommended one for the most balanced approach is to use this Q4KM to run. And then just click load, and then loads the model. I'm kind of concerned with doing this while live streaming because it takes a lot of memory, so I'm not sure if it's gonna. So I'm gonna copy this command. And then test. Yeah, this one I'm not really sure. I think I'm gonna have to study the code first. Because it looks like depending on this is going to determine what files to add to the thing. I think it's just probably the easiest way is just to put the CPP. Oh, it's actually C sharp, so I think it's yes. The files. This whole thing is for the Microsoft Visual Studio debugger, and this Open Debug AED7 is for the GDB one, I think. Obviously, I didn't spend too much time. I just used ChatGPT, then went over superficially, so I kind of get it, but not really. Okay, so I think it's probably not worth it to do this while streaming. I will use the local models. The idea that I have is to figure out like how to automate everything. So there's also two different things that it's not really confused. I guess it's because I studied this before, but like it's two different methods that you can make because the problem, the bottleneck when you're working with LLMs on large code bases or large projects is that you're gonna have to break down the conversations into different chats because of the context window. So as far as I understand, the context window is basically the size of the input that the LLM can take and incorporate into its own model. So every time you are saying something, it's like you're adding that thing to the road view of the LLM, let's say. And that's the context window. So after you go outside of the context window, then the LLM doesn't understand anymore what you're doing. And then you have this other thing, which is retrieval augmented generation. It's called RAG. And this is basically the same principle, but instead of adding to the model, to the LLM model, is allowing the LLM to use external resources to incorporate the thing. So it's basically like for a human being would be the difference between understanding something by memory, by your own memory, or going to search for information on a book or a website or something like that. So searching information for on a website or a book would be the RAG way, and remembering the information that someone told you would be the context window. So how much you can remember from what they told you. And the other for this RAG to work, you have to, you don't have to, but I think it's more optimized to figure out how to translate the information to vectors of numbers, obviously. Which I think that's LangChain is the most famous one, and this Pocket Flow I think is kind of like a variation of that. I'm not really sure. But one thing that obviously I'm thinking about is converting the source code into these vectors, and then like creating a pipeline for automating the process. So I'm just gonna try to run this here. So it looks like I hit a limit. It's probably because it's a different request. But the first one that I did was just to run the file, just see if it was gonna work, and it did return a response. So I think that it is working, but the 401 is probably something to do with the API because I haven't done this before, obviously. I'm just gonna see. This one comes from the repository. Ripple patterns. Oh, I think it's on the crawling the problem. I wanna try with the local path. I'm gonna create a folder on this one. Yeah, I think I'm hitting the limits on GitHub because I don't think I logged in or whatever. This other problem, obviously, I'm not really sure what it is. Private files. So it's because of the files. So I'm gonna try with the local. Also think I downloaded this. Yeah, it's me engine. For the projects, I think that's probably. I'm gonna create a projects folder here, and I put the folders here. I'm gonna copy for now. I think the main one is probably me engine, then the VS Code CVP tools, and the C line. I need to study this tree, then change them. Project or projects engine. Fluent. Yes. Yeah. Let's try this. I wanna this one because I'm not really sure. Like, be careful to not leak anything. And now it looks like it crawled through all the stuff. Let's see if it's gonna work with the LLM. Things that I don't understand. The video is not very clear the way that he describes. Because on the video he opens a website, so I'm not really sure if it's this source code that on the repository that is supposed to open the the website, or if he's using another source code and then he's using this as the backend to communicate to the LLM. Now is a problem with the shard. Let me So it's probably because of the way that the call LLM code I got from ChatGPT and then just replace or just like made small changes. I think it's based on the. It might be because of the way that it was before, that the way that it expects to send the request. Yeah, requests to large for model organization, service tiered on demands, on tokens per day, limit 500. As I think that I hit the limit on the requests. They're blocked. So let's think about this. I'm gonna send a message. So there's two different chats that I'm going over there. So one is one provided by him, which I think is a GPT on ChatGPT that is aware of the project. And the other one is just ChatGPT, the normal thing. So let me think about this. It might be better to spend a bunch of time studying the code first to see. And one thing that I don't understand, I think I probably need to write the questions that I have here and try to clarify them to have a more clear model of how things work. The thing that is confusing to me is that obviously I think that the mental model that I have now is that it's gonna crawl the files, gonna get all the tags for the files, then it's gonna send that on the request with additional information, which are the prompts. It does a string formatting to put the information for the code, and it puts everything on the prompt, then sends to the API call. The API call uses the LLM to process everything, and then this is the part that I'm not sure. I think that what they do, like based on the way that he formats everything, the LLM is supposed to send back JSON files, I think, or something like that, or whatever files are necessary to open as a project somewhere else. But I'm not sure about these other parts, like how it works. So I have to clarify the whole process and then figure out how to optimize. But I'm trying to see, maybe what I should do is pass one file to see what happens. So there's a bunch of different alternatives. This. The next easiest thing to do is to test with the Open Router API. So the other I imagine obviously makes sense for to have the limits. Otherwise, everyone would abuse the system. This is the first obvious, I think. So I think that the limits is the thing is that the tokens are obviously not equivalent to words or characters because it's a different thing. I think it's a different way to format the information. So you can't really assume that it's going to be 500,000 words. I think it's a lot less. And even if it is 500,000 words, I think that's the source code is too much. It's too big. The MIE engine. But the other thing that I can do is pass the. I think instead of passing the whole thing, I'm gonna pass the open this path here. This is probably one thing that I can do because then obviously it's a lot smaller, but I still think it's not gonna work. So let me think. So so one alternative would be to use Open Router to try Open Router. The other one is try to see what happens when I send less files. The other thing to think about is whether or not it's worth it to study the thing first to clarify, because then like the risk is it's not big, like it's not a risk really because everything is free, but it is kind of annoying like if I waste API calls trying to figure out. So for that reason, I think it might be better to clarify the process first, try to optimize, and then test with something. But it might be, in order to clarify, it might be better to send like one file or very small subfolder to see what it returns. Let's read the rest of the thing here. Also what was the output? Defaults dot out. I guess because it broke before it didn't output anything. I have the logs here. These ones are the ones that I did before to test, and then I got the response. Yeah, so yeah, that's basically what is happening. I think it's gonna use string formatting to put everything on the format that the LLM's gonna understand. The question is, what is the response? I'm gonna initialize a new chat with ChatGPT and then go over each thing. I wanna ask what is the best strategy to do this. So it saves output here. I'm gonna do with a subfolder first to see if it returns everything, if it returns anything. Let's try these properties. There's a problem, the logging as well. Logging error. Oh, input. There's a problem with the character. I don't care about this though. But there's another issue. I think it does look like it did work with the call now. There's an issue with the response though. Response. I'm not sure if you try to execute the other one there. I think the problem is the index on the last message, but I'm trying to understand the flow here. Like it has to be, I think like because of the either it's not returning anything, or it doesn't return something that has more than one index. But obviously, if I don't understand the rest of the thing, they might be supposed to fail if you have this, because it didn't return anything. So what is the best function? Obviously, I can print the response. So I do think that it ran this thing. So we run. I think that the rest of the stack is after it hits the exception. So it's running this function. Let's see if we changed anything on the tokens on Grok. So it definitely increased the tokens. So I'm gonna initialize another chat with ChatGPT, and I'm gonna ask what it thinks. Yeah, I think that ChatGPT doesn't. I I posted the whole thing, but it thinks there's a problem with the logging, which I also think it does have a problem with the logging. But this problem specifically is something else. And based on the documentation there, I think that if it worked, you should put something on the output folder. It doesn't have anything here. So I think that because it crashed here, or because it crashed here, it didn't return anything. But I do think that it can't be like it could be. It has to be something to do with the response. The main question I have is whether or not this is wrong by the codes, or if it was something wrong with the response that it is not supposed to have, because the format's always supposed to have more than one thing here. So I think that the response is gonna be this format probably. Yeah, so it has to be based on the response, because when it splits based on this, it's gonna create this thing here, and then the other one's gonna be the whole thing. So it means that the response doesn't have anything. So I guess like the easy thing to do is to just do this. The thing is, I wanna avoid using too many requests just to solve this. And it looks like it is on the first one. So this whole code is basically extracting whatever is inside of the a thing here, the call. I want to see how they do it again. I want to copy this one. Now incorporate the other stuff here. Delete this. I think honestly, oh, it's probably because of this as well. So I have to think about. I'm gonna read the documentation. It looks like it is basically the same thing. It's just the difference is the model and this response formats and other stuff. So I'm gonna look into the documentation. Our choices, zero message. Raise this stuff. Because the thing is, I'm not really sure if I'm able to use the O1 on this API that I have. And obviously, depending on which LLM you use, the output's gonna be different. Obviously, some LLMs are gonna understand more. I think I'm gonna use. I'm gonna base on ChatGPT, but there's also the trade-off of the requests, like how many you can do. So I'm gonna paste the table on ChatGPT. I'm gonna ask which one it thinks I should use from these ones, then replace the name, because now it has a one there on the example. Okay. The thing is, I'm not really sure if it's listening. Memo force call. Oh, this one. So I'm gonna try again. Because if it doesn't work now, then I know it's something with their codes. But even, like, it's kind of weird if it doesn't work. It might be something to do with the API or something like that. So it doesn't have reasoning efforts on the API. The example again. I'm just gonna remove. I think it depends on the model. There might be. I'm just gonna remove for now. I'll think about this later. I want to see what kind of format it puts on the output and how to visualize the format. It doesn't have a store also. think it was. So like the error is happening because of the parsing. I'm not sure what's the best way to solve this. Yeah, I think I'm gonna have to spend time trying to understand how everything works first. It's like I'm not used to YAML or however you say the extension name. These formats. So like one thing that I can do or can try to do is to change the way that the format's gonna work. So I think I have to clarify first the whole pipeline, how it works. Oh, it already has on the input patterns here. I think I don't need to pass. I have CPP. The other thing I can do is to set up the launch.json file. So it's not that hard actually to set up for Python. Like the hardest part of setting up the debugger on VS Code is the debugger adapter. And the most confusing for C++ was the types. But now I'm pretty confident that that's how it works. The types only matter for the extension or for whatever code you're going to use to find the adapter. And then for Python, it's probably going to be inside of the VS Code code. It is going to search for the debug py and then it's going to find the Python adapter and load the Python debugger. So let me think about the options I have here. I think that the thing is it could be something to do with the response, like, but obviously it has to do. It could be because of him using Windows and maybe he did on Linux, and then the translation of the character type is different. Or it could be something to do with the API because by default like this is the default one, and he recommends using Gemini, which obviously I can't use because Gemini is going to be paid. So I think that it has to do with the format of the response. I think that the way it works is that it's going to build the prompt format of the string, then it's going to do the API call. Then based on the way that it does the API call, it's going to return a response, and then it expects a certain kind of response that is going to be probably on YAML formats or however you say that. And it's going to parse based on this. So it's going to save the YAML file. I think that it expects this kind of response here, like with the string formatting for the code. I don't think it has to do with the indentation. So it's probably something, it could be a character thing because it's saying that expecting document start performs scalar. So another thing I can think about is how to ask GPT. But this again is the problem like here because it's not gonna have the context. I think that because it is a recent, it might be a recent code base, maybe ChatGPT doesn't have in training data. And it doesn't. So let me think about how to. One option is to go over with the debugger. I don't think the problem is the API anymore. I think that the API is correct now. There might be some other issues, but I think it is like he's getting the response. He might be getting the wrong response formatting once. So this is the prompt. Exclude the files like this. Okay. I guess I can go. It's probably easier to go from the main. Just see how it gets here. To see what is the state of the variables. Determining. To give the following projects abstractions, the relation for the project. Thus, action of this. So it puts everything on this prop runs. So the prompt is here. Hey, it can't be the prompt. It has to be the response. Let me. And the thing that is kind of weird is that it doesn't seem that it has anything. Like it doesn't specify anything for the format of the response. It, so obviously the arguments here are going to be the ones that are passed through the command line. I assume that this is just gonna crawl over the thing, maybe. Match ripple. One thing that I don't understand is how is it possible to have the thing here. I guess it's gonna use this later. Let me close everything. I'm gonna start from the main. Uh, Don't remember what's, yeah, this was the command. I'm gonna copy this one there. And so here, so I guess you put main here, and you put the arguments on the args thing. Links on VM. Actually, I think you have to do line by line on this, like one commands at a time. That should be the other way around. Actually, I don't think I need this because it already has on the defaults there, so I'm gonna remove. And the exclude as well is probably just have on the main. Yeah. I'm gonna go over manually first. I'm just setting this up in case I need. Close this other one. Doesn't work, it just asks GPT for another one. And keep iterating. Yeah, but obviously, so the way that I think it works is that's gonna parse the arguments you pass there. Then it's gonna create this dictionary of the arguments. Then it's gonna send this here. The one thing that I don't understand is because it's running from here. So this one is gonna return a class, I think. Thorough flow. So flow starts batch ripple. Not sure if I understand this. Like this is a shift operator as far as I know, and it shifts bits to the left. Not sure if I understand here if it is overloaded. I think probably not. It doesn't seem that it is. But on Python, as far as I know, the way that you overload operators is using the dunder methods. If you put double underscores, double underscore on a couple of special methods you can do, like add, for example. You can put that method inside of a class, and then it allows you to determine what behavior is going to happen when you add that class to probably another instance of the class, or I think it depends. I'm not really sure on Python how it works. But I know that it is true for changing the behavior of what happens when the class is used with the operator. So I do think that it determines it allows you to determine like what happens depending on the type of the operator. But I don't remember really well. But I think it doesn't do this here with the shift. So I'm not really sure how does this work. So I'm gonna ask ChatGPT. But here, obviously, like on an intuitive level, it's just initializing these classes here with the state, and then is like wrapping everything inside of this flow. And this allows it to call the other function here. And when it calls from here, it's gonna have the states of all the other classes embedded. The thing which is gonna determine what happens with the information that it got from the command line. Okay, obviously, it could be like calling from somewhere else as well, from another class. This bucket flow is the base repository there. That's they built this on top of. Yeah, so it's probably coming from this one. So the run is probably coming from here. But it's still calling from the other one, which doesn't make a lot of sense. Or it just doesn't do anything. I think you can use these different other ones if you want to do something to prepare the prompt or something like that. Yeah, so I think what this is doing is like this one is not gonna do anything. This one is gonna call this. Just gonna copy this start node. Gonna run. I think that the way that the framework works is based on like a graph. So all the LLMs are just graphs because that's how machine learning works. It's basically a directed acyclic graph based on the way that not sure how to say his name here, but he explains it very well. And it's basically if you're gonna do it in Python, you're just creating a class. You're creating a class and you're overloading the operators. So it allows you to build these graphs from the classes because the classes have encoded into them what's going to happen when you multiply everything or when you multiply or when you add. And then you connect the classes in this way, forming a graph, which allows you to shape the weights of each class based on the cost function and the data you're receiving. So basically, all that machine learning is going to be is finding the closest function pattern to fit whatever data you're putting into the model. And then everything else is going to be like optimizations on top of this. So here, I think what they're doing is something kind of similar, but obviously it's not from the LLM side, but it's basically the same idea, where you do like you split commands based on nodes. Then each node does something, and I think that's what is going on there. It's probably I'm gonna try to go over with the debugger because it's probably easier to see exactly what is happening each time. I think I kind of get it. The run's gonna be here. The prepare is gonna do anything. What is this start? The start node is gonna be from here. Be this fetch repo, just come from this stuff. Just I wanna ask GPT how does this work? If it's gonna be it is a right shift. It does overload here. Or it overloads on the base node, so because all the other classes probably inherit from this base node, they're gonna have this behavior, I think. So it's gonna do this basically. Solve nodes action. Well, I think it's stacking the actions for each one. That's what's going on. Self successor. Then it returns the original class. Or it returns the other class. And so I think that what this does is like builds the graph. So each class builds a part of what's gonna happen on the flow. And then this one, it's you're building the connection. So like it's as if each class is a node, and then you're creating the edges based on this operator here, because it's overloaded on the base nodes, and all of them are gonna probably inherit from the base node. Yeah. So you're creating a flow of actions of what you want to happen. So first, gonna call the logic here, then this one. Yeah. So it is like the name says, obviously. It's gonna fetch the repository if you have any. If you put the local, it's probably gonna be here. Then it parses the logic, analyzes the relationships, writes chapters, and combine tutorial. And I think after it does all of this, then it does the call. Starts. Yeah, so it's gonna use this one on this thing here, and it's gonna get the actions probably on a linked list of parameters, and then it runs for each one. So each of these runs are gonna depend on the class there. Yeah, I think it understands. So for each class on the pipeline, it runs this run function, and each one of them does something. But I think for the stuff that, like this problem here is probably not that. It's probably the final one. So it's on the identify abstraction. So it is on the first one. Hmm. Now let me try to go over with the debugger to see what is going on. Yeah, so it is calling this thing. Yeah, I'll call the same for all of them. So it builds the graph, then it creates the final thing based on the first one that it wants to call. It starts now, obviously, as the name says. It's actually very well done. This is the part that I'm not sure. So it doesn't do anything, and on this one it does. So I think that this does a deep copy. I think it's kind of weird to understand. I guess it's because of the way that it calls. I want to understand what are the parameters here. I guess it's not gonna be anything on this case because it doesn't have any parameters. Oh no, it is the shared. Oh, it is none because it doesn't pass anything. Yeah, so this is not, it doesn't have anything except its own parameters. Let's keep this. I'm not gonna pay too much attention to this because it's just gonna maybe later I'll spend more time trying to understand. It's just gonna traverse whatever directory we pass there, and it's gonna put the files or folders inside of a data structure. Maybe you should like see the formats. So it's gonna read the file, put on. So it's gonna create a dictionary of the path. Is mapping the path to the content of the file. That's what it's doing. And then it's gonna put this on. So it's a nested dictionary. So the first key is gonna be this. The other one is the relative path mapping the content of the files. I'm gonna go back. Yeah. So dictionary of all the files. So now I guess the items is gonna get the key value pairs, I think, and it transform them into a list. So it looks like a dictionary. Uh, Okay, now what's after this? Oh, so this is generating the YAML code, I think. So create a nested dictionary, then it does some stuff here, puts on the information here, and puts on the class state, the values. Any formats should YAML or however you say that. In order to actually send, I think. Yeah, so this is gonna return this context, this file information. So this is the function basically that is formatting everything on YAML. Send it to the LLM. So this should have the values. And now it is the, I'm gonna put this to not leak anything. I'm not gonna go into the API call as well, just gonna see the response only. Like, it looks like it is getting a response. Yeah, so it does. It did return a response. Based on the provider code base context, I've identified the top 5, 10 core more important abstractions, blah blah blah. Microsoft, blah blah blah. And it does look like it is formatted on YAML. YAML string. I'll be right back. The thing that is kind of weird is that it removes the YAML stuff before on the previous line, and then it calls this thing to save YAML format, which is the thing that I don't understand. That's one thing that I have to figure out. Yeah, but maybe the rest of the string is formatted in YAML, so it makes sense. One thing I don't understand is if the whole point is just save on YAML format later, and then it allows you to, from the YAML, you do something else, and then you get the document pages. That's what I want to clarify. Because if that's the case, then I can obviously change and save on a different format, save on JSON or something like that. And then load. But I guess like I can do a bunch of different things as well. It might be interesting. I think I already understand like how everything works. It's kind of the most confusing part that there are nuances. So it's both the parsing is very confusing. It's just a confusing thing by nature, I think. And the other thing that is confusing is the relationship between the classes there, because the code is like very short based on the way that they did it there, which like it makes sense, but it makes it harder to understand how it works. But I understand the general concept. So you build each class with an action. Each class has embedded actions. Like it allows you to create a graph of actions based on the class that you create, and then you can put a sequence based on the shift operator. So the R shift determines the edges of the graph, and each class determines what actions are gonna happen at each stage. That's basically what is happening. So it parses the command line arguments. Based on the command line arguments, it builds the pipeline of the graph, and then it extracts the information for each file. It parses each file, puts in the correct format on YAML formats, generates that context string, and puts that thing on the prompt, does the API request. API request returns on YAML formats. It removes the YAML special thing there. And then the final string, it does this other stuff. I think it tries to save on YAML formats, the final string. So I'm gonna run this out. Or I'm gonna go until it fails. To see at what parts exactly. So it does look like it worked now. It didn't fail on that abstractions thing. Just gonna press F10 until it fails. So obviously I think that the problem is on the parsing. There's something going on with the parsing. Because this is where the most of the complexity, because you're parsing code, there can be like a lot of edge cases that are gonna mess up the format. I assume that's the problem. Maybe not. It looks like it is working now. Weird. I'm gonna do a Skyly draw flowchart of how it works. And I'm gonna spend some time studying like each class on how it works on the actions. Once I have a clear flow of the pipeline, then I can think about how I can change the different parts to optimize the cycle and to change to do other things. I wanted to incorporate the local LLM from text generation web UI now, but I think it's probably not worth it because I'm planning on doing this already on Godot. So I think it's probably better to just use this stuff. The thing is that like I have to see how the final output of the learning documents are gonna be, because it might not be as helpful to learn everything. But if it is if it is helpful by default, then I'm gonna use that to study the repositories I have to study, then create the adapter to solve the. I think I'm gonna study the MI engine for the understanding the Microsoft adapter for VS Code. Then study the extension to see how they connect the adapter with the GUI. Then based on that, this is another part that I'm not really sure, because one option would be to use these LLMs and these tools, like these pipelines, to help to create the project as well. Because on the video, he also says about this, that after you create the design, it becomes easier for the LLM to create the code. Oh, it looks like it worked now. Nice. So it's on the outputs. Nice. It formats everything on Markdown. So I'm gonna ask GPT to see, like, how is he visualizing this? Is this guy here? I think this is the video. I think he's using cursor. Oh, maybe it's this other thing. Oh, so this I think is like the results after doing. So let me think about this. I'm gonna think about, yeah, I'll be right back. I'm gonna think about how to ask to ChatGPT, how to use the markdown files to visualize in the same way that he has here. I assume that he's probably using some other code for this. Yeah, so there are two options. One is to try to figure out with the LLM how to use these tools to help make the LLM help me to create the VS Code extension to debug C++. Then once I figure out how to create the debugger, the adapter, the extension, I also wanted to set up the extension so that like I have a default launch.json and test.json configuration, and I have a default C++ properties or C++ formatting and like other stuff that is kind of annoying to set up on VS Code. So I want to have an extension that I can do everything automatically without having to think about it anymore. So that's what I'm trying to do. So after I do this, then I can see, then there's a bunch of different alternatives. Like I think one of the alternatives, which I'm not really sure if it's going to be a waste of time or not, is to figure out this C line here, or Klein, however you say this. So I'm definitely going to, I think I'm going to study this, but I don't want to use the default one. So what I'm thinking about doing is just changing the source code, removing the telemetry, and also removing, like changing the way that it works so that I can use the local LLMs to work on the. It might be better to do this now because then it's going to be helpful to learn to develop on Godot's. And the idea is to, like, even though it's lower on the local LLMs, you can automate the process. So I can build something similar to what he's doing there. And the idea is to change the pipeline that he did there so that I can create additional tools in order to learn faster. Then automate this process, create the resources. So when I'm not using the computer or when I'm like watching videos or doing other stuff, I can build the resources, and then I can use the resource to learn, make it faster to build this stuff on Godot. Once I have this stuff on Godot, I incorporate the code that I use to build everything on Godot, which I think I'm gonna try to do it inside of the IDE that I'm building on Godot. That's the idea. So I'll be right back. Then I'll think about that. So the first thing that I should do. Also, I did other lists here. The first thing to do is to figure out how to ask ChatGPT about this. But I had another list here of things that I was gonna do. Let's learn C-line, build it from source. How to integrate this. Yeah. So I'll be right back. So for Python, I know that there is Streamlit, and it looks like there is another one, is GDIO or some shit like that they use here. And obviously in Python is better, like it's better to, if you can, to visualize the websites using Python as a server, because then it's easier to incorporate the LLM logic. I think it's probably better to try to do something with Python, and then I can put inside of the same source code here, and something that allows me to visualize as a websites right after. Yeah, so here they use this GR, whatever, radio. I think it's radio, the name. I wonder if there is similar or easier. Now let's try this one. There's also Egypters for Python. I'm just gonna try what it says there. Just gonna copy the commands and see what happens. Okay, nice. Allow me to replace this. I have to go to the project and then serve. And probably replace the files here. Serving here. I'm not gonna replace, I'm just gonna paste there. Nice. Oh, it looked like it is working. I guess it depends on the. It depends on the way that you like. It probably depends on the code it generates, or should it generate the graphs there that he was doing. So I'm gonna ask ChatGPT because here it looks like it's just the documents, which is also very good, but it would be like what I was looking for is more what he shows on the tutorial, where there's the graph of the flow graph of the this stuff here. That's basically what I was looking for. I should. Okay. Now I'm gonna try to. It's kind of weird that. Oh, it might be because of the way that I called from here. Obviously, like it's weird that it wasn't working before, but as this settings here changed the tab here. So it worked when I went over with the debugger, but not before. So I think that probably is because of the arguments that I passed there. I think I'm gonna try to call like this from the command line to see if it's gonna hit the limit. Because obviously the goal is this thing here. But I think this is not the. It's much more interesting to think about like how can I change this to make this better and faster. But I think that's for. It's gonna be very useful once I'm able to incorporate this on Godot. Then it's gonna be exponentially better. I'm gonna delete the. Right. Yeah, so you hit the limits, I think. Crash learned, blah blah blah. Obviously, what I can do is split, but the problem with splitting is that it's not gonna give the graph. Basically, what ChatGPT is saying is that the request is too small to for it to make graphs. It's not meaningful enough. So the issue is if I split into multiple different ones, then like it defeats the purpose because it's not gonna create the graph. But I'm thinking now much more about how to change this flow. And maybe I don't even need. I think I probably don't even need to make the API call. I'm gonna change this code so that I do other stuff. Because I can parse the codes directly and then create the flowcharts. Probably what I'm gonna do is open other chats. Hmm. Or the other thing I can do is incorporate the local LLM now. The biggest issue with the local LLM is that the quality is not going to be very good because the models, I'm forced to use the models that are not very good. Like the models, like to run ChatGPT, it's like you need a bunch of RAM to be able to do the inference. So this is also interesting. Matter diagrams. So the other thing I can try to do is change the prompt. The problem is the size of the. I'm gonna write down here. So like there's two different approaches. I think both like ask ChatGPT. One would be how to. What are the best strategies to break down the requests into smaller parts without losing meaning of the whole. Yeah, the other one is use local LLM because then I'm not limited by the size. I can do everything. And the other thing that I'm thinking about is maybe not even use LLMs, just change the flow so that I get. I think I'm not gonna change the existing code to not mess up the original pipeline. But I'm gonna add another additional thing. Then I just use the same. I still use the nodes. Just change the logic that they do. I'm not really sure. I think that the best paths probably are either local LLM or create a pipeline without using LLMs at all first, and then just see. I think I'm gonna I'm gonna draw on ScalarDraw the flow of the functions. So I can go over with the debugger, write the flow of the functions, then figure out what parts of the. I think the main parts of the process that I can change are the parsing. So it basically consists of traversing the directory, parsing the project, putting on the string formats, doing the call to the LLM, and then receiving the results, and then parsing the results into markdown files. So both this parsing process is the thing that matters, I think. What I could do is parse in a different way using Python. Then without the LLM, just create the other formats for creating graphs, like the one that that's ChatGPT is recommending here, or I can do another one. Can figure out. I'm thinking about. I'm probably gonna use ChatGPT to like create a plan, and then try to do it. This is probably the best thing to do initially, because if I don't need the LLM, then it's a lot faster as well, and I'm not gonna be limited, and then I can use that to bootstrap everything else. But then obviously the big question is like, how is going to be the process? How can I make it more effective? Sure. And this is the thing. Another interesting thing is to figure out like I can format everything into one file, and then I put the file here. That will be another way. So like instead of getting the LLM to teach the code, I parse the code in a way that allows the LLM to format the other thing that I'm trying to do based on this existing code. But I think that the problem with this one is that it's going to be likely that it doesn't work very well. It's not going to be able to translate unless I get a parse in a way, but then it defeats the purpose of doing this in the first place, because then I can just do it myself. So I think this one is probably not. It is a viable thing to do, but I don't think it's the highest priority. It's probably these ones, this two here. I'm gonna ask GPT what it thinks is best. I'm gonna ask on this chat thread, and then I'm gonna open another one to start the plan. I need to think about something that allows me to format everything in a way that is going to be a lot easier. I think like it might be better to format things in a way that it would be easier for both for me to learn and for me to be able to put the final results on the ChatGPT, where I can do manually. I can put it on the chat, either on a file format or just put on. If I parse everything and then put the final result on the markdown, I can just copy the code or copy the text here directly, and then I can use that to study and both to make it better for ChatGPT to help me to create the other code. But the thing is like, but maybe that's like because the thing that I can do is just parse all like both at the same time. Because what I'm trying to do is kind of like glue the projects together. So I have to remove some code from the MI engine for this code for the adapter, and then I have to figure out how to integrate this on CPP tools. So I have to remove parts of both of the code bases and then create a new one. Like, that is going to be separate from both, obviously. And the new one might have like might need other stuff. So maybe I can go over like, yeah, this one is the best. Like I can figure out how to parse the code. So crawl and generate crawl the code. Parse everything. Generate learning resource for myself. So like this one, for example, I could like use this one, and then like on specific parts of this, depending on how I parse the code, I put a prompt on the LLM. Then I extract those parts and I put the whole output. And if it's too big, then I can just create another thing that allows me to. So then I can choose the two routes and probably do both at the same time, where I put one on the local LLM pipeline to automate the process, and the other one I do manually, depending on the size. I can put a limit like 5. They say you put the strings of code based on the limit of the context window that you can do manually. You separate the strings, then you put manually on the GPT one by one to see what it says, and then the other process, which is the local LLM, you make everything automatic. So I learn manually with the resource that I create here, and then I break down. So I can do like a directed graph with explanations on the edges, which would be like the prompts on the edges. The question is how to formulate this in a way that's because obviously you don't know the code and it has to be reproducible. But there's must like obviously there is a it's gonna follow the universal principles of how everything works. That's some stuff is like archetypes that remain the same across time, and other things that have high variance that creates a fund of information, which is the computation, which is space-time. So I have to figure out what are the archetypes of the code bases that I can inject the prompts on the graph that allow me to learn faster. And the problem is the parsing though. That is the issue because it gets too complicated, I think. At least for now. Like you can figure out a way to do it later, but because the thing that he's doing is he's not parsing anything, he's just traversing the code and then he's just extracting the raw code without any information. And then he lets the LLM create the graph. There's like a different thing. It's like using the LLM as a parser, but is not very good. It's like better to create a structure parser, but then it depends on the language. That's the issue. Like create a structure parser, create the graph, then you embed the LLM later based on the structure create. And the question is like, what is the best, most effective way and the easiest way to do this now? I'm gonna ask this ChatGPT. It's roughly. the thing that I like the most about this is the way that they did. Even though it's a little bit confusing, I do think it is very good. This thing about the classes, the thing that it is kind of annoying is that it kind of forces you to use inheritance, I think, based on the way that it is here. But it's not that big of a deal. So it is very nice because it is very easy to visualize how it works. You just every time you want to create a new type of action, you just create another class inherit from the base one, and then you just build a graph like this. It's very this. It's very easy to understand the pipeline. So this is what I like about this. I think the thing I have to clarify is exactly like what is. I think it's probably gonna follow the same line for each class, like the prep, and it's gonna be based on the base class, obviously. I think. So you have the prep, then you have the execute, and then you have the post. I think. Yeah. I think all classes have these 3 steps of the pipeline. So you have to pre-process the action. I wonder they have to be linked. I think as well. This is the part that is not very clear for me yet. How the action was linked, and it's going to be based on the shift operator and the state of the classes, obviously. Yeah, so I think that all classes are going to have these methods. They're going to implement most likely the run and most likely the execute. Yeah, the execute is the one that all classes are going to implement, probably. Maybe not actually, depends on the relationship between the classes. I think I'm going to use the same structure, just create a different thing. I think I'm probably going to have to change anyway. Yeah, I was thinking about the three-seater. This is the reason why back some time ago I was interested about the peg parser from Python, because basically the same idea. Have a code that generates like a dynamic thing. You can use like an abstraction to parse any language because it's just a graph. And then you format the code in a different way. And this is good. So imagine what they are doing here. The main implementation of Python, as far as I understand, is CPython. And what you can do, as far as I remember, with CPython is to add add C code into or add extensions. So I imagine that's because as far as I know, three-seater is built on C or C++ or something like that. But it works for other languages as well. I didn't study too much. I think I just read like the beginning of the docs on three-seater, but I know it's something you can do. You can use to parse languages or something like that. And I think it is written in C or C++. So I imagine they did it as an extension for Python. So you put C code inside of the CPython compiler or something like that, and it allows you to extend Python. But the good thing about this is that if it is like this, then I can figure out how to translate this to C++ later to incorporate on Godot. I'm not sure if this parses Python or if this is the three-seater on Python to parse everything else. I have to study the documentation. I'm gonna ask ChatGPT to outline a step-by-step plan to summarize and put on the detail format so I can use it as a context on another chat thread. Then I'm gonna put that context and I'm gonna start changing the I'm gonna go over with the debugger on the thing, clarify the relationship, probably use SkyDraw, I think. I use SkyDraw to draw the relationship between the flow, like how it works there, and the functions that matter. Then I create some other folder, put the or copy some of the codes, copy the same code, the same classes, and change the name of the classes. And then change the I think probably I'm gonna see if I can comment out the API call, obviously, because I don't want to waste. I just want to see, clarify the pipeline. So comment the API call, go over the pipeline, draw and schedule draw, copy the code, choose somewhere else, change the classes, figure out what parts of the code I have to change. Then after I do this, then I focus on the three-seater. Looks like it doesn't. Yeah, so the documentation is this one.
itself is written in C, and its parsers are embeddable. You can compile them into Godot++ as native libraries. The IR view pipeline can be split into core class code entity, public ref counted. Add importers that build this IR from disk. Later replace the tree sitter Python glue with C bindings in C++ via tree sitter C API, then hook into Godot UI. Yes, the strategy I outlined is very well suited for eventual translation into a Godot C-based system like your Celerity fork. In fact, designing it now with a clear IR intermediate representation and modular architecture will greatly simplify the translation later. Let's break this down in two parts. Part 1. Why this design translates well to Godot Celerity. Why the unified IR strategy works. It decouples parsing from visualization and analysis. You can create Godot classes like CodeEntity, CodeProject, or CodeGraph that mirror the IR. Tree sitter itself is written in C, and its parsers are embeddable. You can compile them into Godot++ as native libraries. The IR view pipeline can be split into core parsing logic C++ and Godot, UI logic Godot nodes, optionally editor plugin if you keep editor tools, later LLM enhanced backend as an offline process or coroutine. By writing the Python version now in a modular way, you can systematically re-implement it in Godot later, step by step. Start with the IR structs, mirror your Python CodeEntity as struct CodeEntity or class CodeEntity, public ref counted. Add importers that build this IR from disk. Later replace the tree sitter Python glue with C bindings in C++ via tree sitter C API, then hook into Godot UI or your custom UI engine to render it all. Suggested Godot structure later. CodeProject.gd holds files and project-wide metadata. CodeEntity.gd base class for all function class module wrappers. Add importers that build this IR from disk. Later replace the tree sitter Python glue with C bindings in C++ via tree sitter C API, then hook into Godot UI or your custom UI engine to render it all. Suggested Godot structure later. CodeProject.gd holds files and project-wide metadata. CodeEntity.gd base class for all function class module wrappers. CodeGraph.gd manages dependency and call graphs. CodeViewer.gd UI that lets you click through, expand collapse views. Later maybe CodeElmAssistant.gd queries LLMs for insights. All these can evolve from the Python prototypes you build now. Part 2. What is tree sitter? Tree sitter is a parser generator tool and runtime library for building fast, efficient parsers. It is used for code editors, linters, IDs, and static analysis tools. How tree sitter works summary: you provide a grammar written in JavaScript like peg rules. Tree sitter generates a parser in C. You embed the C parser into your tool, can be used from Python, C, C, Rust, etc. You feed it code. It returns a concrete syntax tree, CST. The CST has tree sitter. Part 2. What is tree sitter? Tree sitter is a parser generator tool and runtime library for building fast, efficient parsers. It is used for code editors, linters, IDs, and static analysis tools. How tree sitter works summary: you provide a grammar written in JavaScript like peg rules. Tree sitter generates a parser in C. You embed the C parser into your tool, can be used from Python, C, C, Rust, etc. You feed it code. It returns a concrete syntax tree, CST. The CST has types, spans, and relations, perfect for extracting symbols. It can incrementally parse large files, great for fast updates. Handle syntax errors gracefully. Be embedded in editors like Atom, NeoVim, VS Code. Capabilities: supports dozens of languages: C, C, Rust, Python, JavaScript, TypeScript, C#, Go, Java, etc. Many official and community grammars. Parses raw source code into syntax trees, which you can walk, query, or convert into custom IR. Supports tree sitter queries, like selectors that let you match function definition, class.declaration, etc. Tree sitter language bindings, written in C. Parser runtime is a single .c and h file. Bindings exist for Python tree sitter, Rust tree sitter crate, JavaScript node, C. You can embed the runtime into Godot C++. You'll just need to compile the parsers and link them. You can even use Rust plus C++ interop for a Rust-based parser module, since Rust tooling is more mature with tree sitter. Pipeline translation path. Now, Python later, Godot, C Python viewer classes ++, ref counted resource tree sitter Python tree. Sitter C API and Godot trick, HTML for views Godot2D UI prompt heuristics ++ rules. LLM optional file traversal dir access, file access. Next steps I recommend. Design the UEIR format now in Python as dict or dot class. Build language frontends using tree sitter Python binding. Modularize the pipeline to have clean parser IR heuristics, IR view. Once it's useful, mirror the UEIR structure in Godot C, then migrate the parsers and reuse your logic from the Python prototype. If you want to visualize now, just build HTML or a terminal interface. Later, use Godot's tree, code edit, graph edit to build native views. Would you like a starter UI design in Python, or a minimal example with tree sitter parsing C++ code into CodeEntity IR? I can set that up for you right away.
So I'm gonna comment out the API call here. Also, I'm gonna comment this out as well. Just gonna do a pass. And then I'm gonna go over with the debugger and try to, so I'm gonna open SkyDraw and create a simple flow chart of the functions to, and this like a small graph to figure out what parts I need to change. I think I have to log into SkyDraw. Not sure. Oh no, works. Oh, let me think. This is I think it's just all self parameters are the same for each one. So this part's not confusing. The part that's confusing is the other one. So this is one. So the other is the one on the right, and the self is the one on the left. The self the next, other. This is the nodes, action stuff. So it didn't pass any action. Overriding successor for action. Okay. What do you think about this? But I assume that's it's calling from the this self, no. The successors should be the one that comes after the, I think. They're just warning that is the same action, but I'm not really sure if I get it. So it puts the action on the map with the node. Is the other self-successor. Is mapping action to the node that comes after, I think. Let me think each node is gonna have its successors action. So I think creates a linked list here. This one is the same. And they're linked by the actions, I think. So the question is how are the actions related? think it probably loops over them, and then for each one it goes over the next. So it's like a flow chart that is based on the action. So the start is the first one. It starts off with the run. Just flow, run. I don't understand why it checks for successors there. The first one. So it's gonna call. So the last one uses both of the first ones. It prepares, then orchestrates, I think. Then on the final one uses both. Does this return? Passive. So it's just like iterating based on the current. An update select the last action based on the run of the current. It's basically the same thing. What is it's probably parameters. And this part's the one that is a little bit confusing because it can change based on the way that each class is created. It's kind of confusing to understand. So just looping over and then this moves though. I think this moves. And this moves the next one. And base node again. It's gonna have the actions. So this one has this. Yeah. So it goes from here, creates a loop like this. And then as it creates the loop, it traverses the graph. Hmm. Yeah, so this is the problem. I guess this is the thing that makes it confusing is the inheritance. It's gonna change the loop based on the tree functions, based on how you implement the classes. It's not like it isn't that confusing, but I think that it might be possible to make it easier to understand. The problem is I think that they do it with classes because of the operator, overload operator. It does feel very good. It feels that the code is very good. It's just confusing to understand by default because it's complex to do, I think. This is probably from the first one still. Or maybe not. And this is what I want to choose. I think I get it. So it's not that hard. All I have to do is just copy this stuff and then I change the execution for each one. The pipeline is basically the same. I think for some of them I have to change the prep. So the question is which ones are the ones that parse and do the call here. This one obviously does a call. So I'm gonna copy this file into another one, and then I think I'm gonna put it on the same folder. Just change the names of the classes and change the code of the pipeline. And then this is on the utils, the last one. I'm gonna traverse the project. So this is inside the loop, it moves the iteration. So now the current is gonna become this one. And it runs for usage prepares, executes. It's probably gonna break because it doesn't have the LLM call. I guess like maybe I should go again because I still have to clarify like why does it matter on the moment that they are linked, which I think is based on the actions. How does it? But maybe it's failing because it's from the node. Like the logic of each one is not dependent on each other, unless you make it so based on the actions. But I think it's just failing because the execution of one node can't complete because of the API call. It's not because of the other nodes, I think. Or maybe not because yeah, I don't understand that parts there. Like why is it calling that execution on the accept block there? At this one it could be improved to check, but I think it doesn't matter. At this one is the one that I don't understand. So max retry is the one that you pass there when you're initializing the class. Yeah, executions. I guess it's because of the retries. So it goes through this one once this fails. But I don't understand. I guess it's just for API calls that you use this. So just don't like this should fail. I think that the errors that I got, they're not because of the relationship between the nodes. They're because the logic of one of the nodes fails. And I think that the way that it links is based on the map of the successors and its for actions and nodes, and that creates a traversal of the path. Yeah. Let's make it easier to understand. As on this one, that is going to loop. Oh, so the post is the one that returns the action. This is the part that is confusing to understand. Because like this is gonna be based after like all of them are run. That's the part that I don't get. So it runs this. On the first one would be the first class, which is the fetch repo, I think. And then it runs the function again for that one. Then that one prepares. So I guess it hits the limits of the. But it doesn't make sense. It's like, how does it know the action? I guess the action only matters when you're backtracking, I think. Yeah. Like for the execution doesn't matter for the preparation and for the thing. It's mainly stacking the preparation first. Then once the final one is hit, it's gonna go back. And then it's gonna use that to get the next action. So it executes, so it does the preparation for all of them, then it does the post. Where is the execution? I think that's the part that is confusing. I think I'm gonna go over again. Yeah, so I have to clarify, like, what's the order that they execute. And once I do this, then I can. But I already know which, like, I don't need to clarify this to know which ones I'm gonna change, but it's probably better because it's gonna make it easier to develop the other stuff if I know this. Develop additional things on top of the classes, and also figure out what classes should inherit from there. Because there's different types of flows as well. I think this part doesn't matter. As on the shift that it determines the classes. Thanks. I guess you can call, instead of doing the shift, you can call from the node the next function and then pass a different action. So if you want to add multiple actions for the node, the maps on the successor map. Okay, so the south should be the flow. So currency is already the next one. So because it starts with this one. So here, I think that this is gonna be the ripple. Yeah, fetch ripple. It's gonna prepare. And yeah, this part. Also here, that's the reason why it's confusing. Here is different. So on the fetch ripple is calling from here, but on the flow is calling the other function. And it depends on the class. So why on fetch? Like here when it runs. I guess because it's using this function here. Yeah, so this is from this class here, is not from the other one. That's the part that's confusing. So this one starts the iteration and the other one does the execution. Oh, and this is for the fetch repo still. Now it's gonna call the get next by passing the current one. So what changes is based on whether or not you pass the action there. If you don't, it passes the default. So it accesses the dictionary of each one and then it gets the node based on the action. It's different. So the main flow class loops over them by traversing the dictionaries of each one. And then for each one is gonna call the execution function or the run function, I think. Yeah, because it's on the same line. So for each one, it calls the run, then it goes over the next. It's gonna fail, so I'm not gonna be able to see. But one thing that is kind of confusing is like how does it make sure that it goes over all of the actions for each node. But I think it's just because it loops over. As the get next node, that is. Though. This is the part that is kind of confusing. It's based on this last section. Hmm. Yeah, so you link based on the post. Whatever we return the post. And if you don't return anything, it just goes to the defaults. So it doesn't allow you to loop over all the actions. I think. Yeah, I think I understand how it works. The only confusion that I have still is whether or not, based on the way that I think it works right now, is that either it's gonna follow the default action for each one, or it's gonna follow the last action. So I think it limits for two different actions. And I was thinking that you can put however many actions you want for each node, and they're just gonna traverse that action. So it will loop over the successors and then traverse. But I think it's just up to two actions. I guess it might depend on the main class you use. So there's the other class there that I think is batch flow or something like this. Yeah, batch flow here. Maybe for this one, it goes over more. Yeah, so I'm gonna spend more time later trying to clarify this more, but I think I already understand roughly what I need to understand. The easiest thing to do now is to copy this file into some other file and change the names of the functions. I think I'm gonna remove this. And maybe I should spend more time just to draw the actual classes and functions that are called in the order that they are called on SkyDraw, and then select the exact ones to change. But I think I'm gonna have to change all of them probably because it changes everything. Probably can remove the fetch ripple as well. These include patterns that don't make sense as well. I want to remove. Hmm. And maybe it's better to start from scratch. I think I should remove, because it's easier to think about the steps. So I should outline the exact flow of functions. Maybe should do one calling the API to follow the whole thing. Then do this kind draw with all the functions and use that as a template for the other one. I think it's probably better to start from remove everything. I should remove all the codes. I can paste later if I need. And just keep the thing and then I think about the pipeline. That's probably the best thing to do. And the main thing that the main way that I connect the actions is with the shared object. This is something that is kind of confusing me as well. It's gonna be easier to think about if I think about the steps first of what I want to do, then think about what is gonna be necessary to connect them. And once it gets to the points of connecting them, I go based on try to understand more how they did it, just probably through the shared object. I think I don't need all these steps as well. Maybe this one I'll leave here. And the thing is, like, I don't need. That's the thing is, like, it's all connected, so I think I have to do from scratch because I don't need all these things that they did are for formatting the prompt, and since I'm gonna do everything differently, it doesn't make sense. I think this like the name says is the preparation response for the previous step. So I'm gonna go over with the ChatGPT, then outline the steps that I think I'm gonna need. I'm gonna remove these classes here. Oh, this one is difference batch now. I'm gonna keep this one that is difference. I'm gonna remove all this, start from scratch. The execution. I think I need to. It's gonna be better to ask the question based on the current pipeline, I think. So gets the pipeline of the flow of execution of the functions for the whole thing, for the original one, then ask GPT how to change that flow in order to do this other pipeline. And once I have the structure, I'm gonna ask based on the way that I can test without doing anything. And once I have the structure, then I figure out. Yeah, so I'm gonna put like one file. I put the path for one file on the thing, on the launch.json. Then I'm gonna do an API call. Then I'm gonna manually write down everything. And maybe I'll stop streaming now. I'll do this off stream. It's gonna be kind of annoying. It's better to use the two monitors. Yeah, I think I'm gonna stop now. I'm gonna stop this. So what I'm gonna do is use the two monitors. So I'm gonna execute, go over with the debugger. Then for each function that it calls, I'm gonna write down the name of the class and the function that it gets called. Then once I have the flow of the functions, I'm going to load up another thread on ChatGPT, and I'm gonna put this. I don't like this very much. The way maybe I'll continue on this one here to get a better summary of what we're doing. So maybe I think I'm gonna ask here. So it backtracks on the post. It traverses, prepares for each one. Like I'm not really sure if it makes sense to do this in this way either. Like there, it might be more simplified to just do everything from scratch and then just call the functions in order. I do think that it is nice the way that it is like set up. Maybe it is good because then I can do variations later. I guess this is the thing that I'm contemplating on is like how to divide each part of the stuff, each part of the process, how to break the limits of what should be the prep and what should be the execution and what should be the other stuff. I think it seems that all of them should be the execution. Noise complaining. Okay, oh yeah, I forgot your. No, it should be. Maybe it has to be Python. Yeah. Doesn't make sense. Oh, maybe I forgot your. Oh, this one. Yeah. Let me think about this. I'm gonna copy this. So I'm gonna do the classes based on this thing here. Of this. Nice on the chart. So obviously I'm gonna ask. I think I'm gonna. I was gonna do another chat threads, but I think I'm gonna ask you first, and then because the structure is very easy, I just break down like for each step you create a class, and then I can ask GPT. I'm gonna ask now, like to break down into. But there is one thing. The first question is whether or not it's necessary to use fetch repo, because I think I'm gonna do it with the local code. But it might be a good idea to leave it with the option to use GitHub or like do requests in general, because then maybe you don't need the code as well. Yeah, like the thing is that there's so many things that are possible to do with this. It's very interesting. I think you should leave like as simple as possible first. Yeah, but then the problem. It should be easy to change the code later if I want to implement requests, I think. I should do as simple as possible so I can test and iterate fast on the local parts, the local code that I have there. I'm gonna ask. Yeah, it might be better to do it because why not? I should just copy the fetch repo from them and change the rest. I'm gonna follow what GPT is saying. So instead of copying that one, I'm gonna send the original one and ask to change for the new pipeline. Comments. I think the fields here have to be mapped to compilation process fields. I could do a control flow graph and a static assignment variable and stuff like this. And I update the shared structure based on the parsing. And then I break down, like I can create a traversal algorithm on the other parts to inject the LLM prompts. Yeah. Then I can create the final files based on that. And I can limit based on a buffer size. To manually put on ChatGPT, or see if I can put the whole file, but obviously it's gonna depend on how big the output's gonna be. And then later I can do the both things of incorporating the local LLM and also putting on the using manually on ChatGPT, or using the APIs, the free APIs. And figure out a way to optimize the inputs that I send to the API requests so I can get more for tokens. I think here it doesn't make sense to but I'm gonna the problem is that the shards, I think this is the challenge, like the shard structure depends on the whole pipeline. So I should probably ask ChatGPT about like clarify the pipeline of each function, or of each class. I'm gonna start with the fetch. So put the code for the fetch, change the fetch parts, and then the other ones I post the whole thing that it did here. I post the rest of the nodes, and then I ask for like for each function whether or not. So I'm gonna ask like let's do class by class, and for each function whether or not the class is gonna call that the function. I should focus on iterating as fast as possible. It doesn't need to be perfect, just needs to work in the beginning and improve later. So I should put the same fields there that it has here. So one thing is the project name. If I put this or not. I think it maybe it makes sense. Because the output folder is gonna map the input one. Maybe instead of project name, I'm gonna put project root. It makes more sense. Or project root folder. And these ones doesn't make sense. Also, I think file maximum size doesn't make sense as well. These ones I can remove. There's a relative path. I think here I don't need to change this because it's just gonna get the dictionary with the path of the file and the content. I can still do the same thing and then just change the other ones to traverse this dictionary. I have to see how this is related to the other ones. How the execution of this. I think it's just like ChatGPT said, it's gonna be from here to here, so this one's gonna determine, gonna execute right after the other one. They put some shared files, I think. Yeah, so it's here probably. I think what is happening, but I'm not 100% sure, is that it's gonna put all the paths here on the dictionary and then it's gonna put on the shared structure here. So I assume that this has to run before the execute for the next step, which is kind of different. No, it is. Yeah, it is what ChatGPT is. No, actually not. It is different than what ChatGPT said. ChatGPT said that it executes the first one, the prep for each one, then the executable, and then it goes on the reverse order on the post. And I think that that's probably not what happens. So the flow is gonna start here, and then this one's gonna be this one. I think it is gonna execute all of the steps for each class first, and then the last section. And then it iterates based on the get next node for the current one. The current becomes the next based on the action. This is like misleading because not looping here is based on the next action. I think like ChatGPT hallucinated there. Each one is gonna call the whole cycle, and then it's gonna move on to the next stage of the pipeline. So it calls the post before. So it puts on the shared here, and then after that is going to call this one, and then this one gets dictionary from here, and then it parses here. So that's probably what I'm gonna do on my thing as well. But instead of parsing like this, I just use tree-sitter to create a different kind of thing. Actually, the easiest thing to do is actually to just reconstruct everything and then just print. I don't know why I didn't think about this before. I can do the same structure that they did there and then just print on each function the name of the class and the name of the function. And then I can analyze. I can just look at the output to see the flow. Makes a lot more sense than spending a bunch of time. Yeah, I think that's what I'm gonna do actually. I'm gonna leave this one like this, and I'm gonna put a print here. I'm gonna comment everything else. It's probably better to do first, so I just copy the codes, the bottom here, and then I just print on each function. Then once I have that, I put on a comment on top of here to remember how it was, and I reconstruct everything, remove the ones that I think are not necessary. Think about like how to structure everything. I'm gonna keep the same name, so I don't have to change a lot. Yards output. Yeah, I think I'm gonna stop now. So I'm gonna do this off stream. It's been a long time here. So probably next time that I stream, we're just gonna continue this. So one thing, like the thing that I'm gonna spend the most time, I think, is the thing about what should be the structure and then the relationship between the classes. Probably what I'm gonna do right now is what I said. I'm going to copy all the classes here, and then I'm gonna remove all the code from all of them, keep the same flow that they are using there, and then I'm gonna print inside of the function the name of the class and the name of the function, and then I'm gonna copy the order and put it on a comment here, so that's very clear, like what is the flow of the functions. Once I have that, then I'm gonna think about like how. Probably I'm gonna keep the. I think I'm gonna have to change. This is the part that I'm gonna have to think about the most. But the overall thing is gonna be the same. So you fetch either fetch the repository or you get from the root directory, which I'm thinking about also looping over the projects folder and then doing for all of the projects folder. So all the main folders I put here, I can loop over from the outside and go over the flow for all of them. But obviously I'm gonna start with only one. So this one creates a dictionary. Then from this one, I'm gonna just change the name of the functions probably. So this part is probably the one that I can use. No, this one I think I can use the same function. It's probably better to just use the same, because just traversing the thing, getting the path and the content of the files. I can just reuse the functions. For this, it's gonna be the same. But then after I have the dictionary with the paths and the content of the files, the next step is gonna be to use tree-sitter to format the code in a different way. Then from that part is the one that I'm not really sure. I think that I'm gonna try to do two things. One is gonna be to use that format to put everything on either create graphs or initially I'm gonna do it as simple as possible. But I have like the problem is that for the more complex ideas, which is what I was trying to do already, like I'm gonna try to do anyway, and it is what I was thinking about doing on Godot. So I think for that stuff, I'm gonna have to like wait until I have the Godot set up. But maybe I can start translating right now as well. Like I don't need to, but I'm gonna do it the simplest way possible here to see how it looks. And the idea is to do the same thing that he was doing, where I'm gonna create files with different structures that allow me to visualize the code in different ways, make it faster to learn. And then the other part of the pipeline is to use the same structure to embed LLM prompts. So I use both the raw resources and the LLM prompts. And then with the LLM prompts, I can either incorporate the code from the text web generation or text generation web UI to do inference locally with the models that I have there. Or I can just save in a way that allows me to manually paste on ChatGPT to break down each thing. And then obviously I can expand on this, like based on frequency and stuff like that. But I'm gonna try to like get as fast as possible to the like baseline, the MVP, without thinking about too much. Because once you have the structure, then it becomes a lot easier to build on top of it. Then I'm gonna try to use this stuff to study these three repositories here in order to do the extension to debug C++ on VS Code. I think I'm not gonna do the C line probably. I think it's probably better to figure out the debug on C++, then go back to finishing Godot, because it's gonna be a lot better to incorporate this on Godot. And once you incorporate this on Godot, yeah, but the thing is, like for the actually maybe not. Like the debugger is gonna be good because it allows me to understand how to do this on Godot as well. So that's the reason. One of the reasons why I also thought it's a good idea to do the debug adapter, because the debug adapter is not specific to VS Code. It's just a protocol that they created to allow an UI and user interface to communicate with a debugger. So I think I'm gonna try to do some variation of that on Godot. But C-line is not related to this, just the VS Code extension, but maybe like depends on how hard it is, obviously, and how much it benefits me to, like how faster can I learn after doing this pipeline here. Yeah, but I think that's the main priority, is to be able to get to the point where I can do this stuff on Godot. But I'm gonna set up in a way that it becomes easier to translate to Godot later. So yeah, next time that I stream, I'm probably gonna continue, or I'm gonna show the stuff that I did, and eventually build on Godot. Yeah. So see you next time.